This is day 9. We have begun working on linear programming, and we're going to practice finding the maximum and minimum value of objective functions and graphing systems of inequalities. So for right now, the feasible region determined by a system of constraints is given. Find the maximum and minimum of the objective function. Okay, so for example, this c equals x minus y, that is the objective function. And these points here are the vertices. So if you want to find the max and min, you want to substitute these values one by one into the objective function. So for example, starting with 0, 0, c would equal 0 minus 0, okay, just x minus y, which of course is going to give you 0. Alright, now moving on to 0, 6. Alright, it's going to give us negative 6. Moving on to 2, 7. That's going to be negative 5. And finally moving on to 5, 0. That's going to give us 5. Now, we're interested in the maximum and the minimum. Alright, the maximum value is the 5. Okay. And let's remember that this 5 came from the point 5, 0. Alright, we're going to need that information. So this came from the point 5, 0. And the minimum is the negative 6, the lowest value here. And that came from the point 0, 6. Okay, very important. So in our final answer, we're going to say this. The maximum value is 5, and we get that at 5, 0. And the minimum value is negative 6, and we get that at 0, 6. Alright, so that's how you will record your final answer. Let's practice that a couple more times. Alright, let's start with 0, negative 2. If I substitute that into the objective function here, that's going to give me 0 plus 2 times negative 2, which is negative 4. If I substitute 0, 5, that's going to give me 0 plus 2 times 5. Okay, so that's 10. Next is 3, 3. Which is 9. And the last one is 5, negative 1. Okay, which is 3. Okay, so one of the properties that we learned about dealing with a feasible region with its vertices and an objective function is that the maximum and minimum values possible will always occur at the vertices. So that's why we can ignore all of the other points, the points all on the inside and everything. We can just worry about the vertices, and that will give us the maximum possible value of this function and the minimum value of this function. So let's see what we have here. So the maximum value is 10, and that came from 0, 5. And the minimum value is -4, and that came from 0, -2. Okay, so don't forget, here's how you record your final answer. We'll say the maximum value is 10 at 0, 5, and the minimum value is -4, okay, at 0, -2. Alright, that's how you'll record your final answer. Alright, let's do that one more time. Okay, so let's just start with, I think I'll start with 0, 3. If I substitute that in, then that's -2 times 0 plus 3. Okay, just substituting the x and the y in right there. So that gives us 3. Alright, if I go 6 and 1, 6, 1, okay, so this is -12 plus 1 would be -11. That brings us to 6, -3. Alright, so that's -12 minus 3 is -15. Alright, now let's try -3, -3. So that's +6 minus 3, so that's going to be 3. This will be the last one. -3, -1. So that'll be +6 minus 1, so that'll be 5. Alrighty then. Okay, it appears that we have a maximum value of 5, and that occurs at this point right here, -3, -1. And then we have a minimum value of -15. That's the lowest value, so that occurs right here. Okay, so we'll write our answer this way. Max equals 5 at -3, -1. Min equals -15 at 6, -3. Alright, what's next? Oh, okay, it looks like we just have a few more of the same type of problem. Alright, I think I'm going to do some of this work off camera. That's what you get from 0, 0. And this is what you get from 0, 4. This is what you get from 3, 5. And this is what you get from 3, 0. So we have a minimum value of 0, which came from 0, 0. And then we have a maximum value of 18, which came from 3, 5. So here's how I want you to write your final answer. Okay. There you go. Kabam. Alright, we got to do this 2 more times. Take a look at number 5. It's going to be the same thing. Okay, so these are the results we would get from substituting each of these vertices into the objective function. And we find we have a maximum value of 17 coming from 3, 2. And we have a minimum value of -3 coming from -1, 0. Please record your answers this way. Okay. I keep having to resist the urge to ask if there are any questions, like I do in the classroom, but I can't hear your questions. So hopefully I've been really clear. Alright, I'm going to continue doing most of the work off camera. Alright, so these are all of the results at this point. And the minimum value is -11 coming from this point. The maximum value is 21 coming from this point. Please write your final answer this way. Alright, let's see what's on the back page for us. Okay. We need to do the same thing we did on the front page, except on the front page all of the constraints and vertices were graphed for us, and on the back page we have to make our own graphs. Now, a lot of students have some trouble when it comes to graphing, so please watch very, very carefully how we do this. Okay, looking at the line x is greater than or equal to 0. In my mind, I'm picturing the equation x equals 0, and I know that this is going to be a vertical line. A vertical line is 0. X equals a number is always a vertical line. So I'm just going to draw a vertical line at 0. Okay, so here's my vertical line at 0. Now, it's supposed to be x is greater than or equal to 0. Normally we do above and below when it comes to shading, but there is no above and below a vertical line. So because it's x's, we shift to thinking left and right. And greater than will be to the right for these x values. So, I mean, notice 2, 4, 6, 8, the values are getting bigger as you go to the right. But don't go crazy shading this whole thing. Just put a little bit of shading to the right. Something like this. Just put a little bit of shading. Just enough so we don't have to remember that this is the side of the line to be on. Okay, similarly, the next equation. In my mind, I picture the equation y equals 0, and I know that this is a horizontal line. So I'm talking about a horizontal line at 0, which is basically the x-axis. Okay, so here it is. I know it's a solid line because it's got the or equal to, same as the other one. Keep in mind that sometimes they're dotted, but both of these are solid. Because this is greater than or equal to, then in my mind I'm thinking, oh, this is going to be above. You know, usually when it's y, like usual, we do above and below, and greater than would be above, less than would be below. So just put a little bit of shading on the above side of the line, just a bit. Okay, just enough to remind us that we want to be on the above side. Now this last one, so just be very careful how you rearrange it, but we have to get this y value by itself. So you want to subtract x from both sides like this. I don't know why I did that. Alright, so that's going to give us y is less than or equal to negative x plus 4. Alright, so when we graph this, in your mind you should be thinking, okay, this is like negative 1 over 1. So we start off with a y-intercept of 4, and then I'm going to go down 1, right 1. Always go to the right. Okay. Now we know that we have to be to the right of the blue line and above the red line. So basically we have to stay in the first quadrant. So really we know it's going to be only this portion of the purple line is even possible. Because this is less than or equal to, again, we know we have to stay on the below side of the line. And this is the side that is below the line. Alright, so the solution area, the feasible region, is going to be the zone that satisfies all three inequalities at the same time. The zone that's to the right of the blue line, above the red line, and below the purple line at the same time. And hopefully you can see that only this triangle right here satisfies all three. So this is the feasible region right here. Now, we need the vertices, similar to the problems that we were doing up here where they gave us the vertices. We're talking about the corners. So we need to identify those. This corner right here is 0, 0. This corner right here is 0, 4. And this corner right here is 4, 0. So those will be the three vertices. Alright, now to finish this off, we need to do the same thing we were doing on the previous problems. We need to substitute these vertices into the objective function one by one and find the max and min. Okay, so remember that the objective function is c equals 2x plus y. Alright, my daughter Maya just got home from, where did you just get home from?
A birthday party.
Alright, come a little closer. This is the microphone right here. And she wanted to say hi. What kind of birthday party? Where you
I
at?
went to Stars and Strikes, but I didn't get to go in the bumper cars.
Why didn't you get to go in the bumper cars?
Because I have a broken back. I also didn't get to go to laser tag.
Aw, did you have fun anyway?
Yeah, because all I did was play video games.
So that was fun playing video games?
And I earned tokens, and I'm going to save up for the next time I go so I can get the phone at the top of the prize.
Alright, how were you able to walk around with a broken back? Usually when people have a broken back, they're in a wheelchair.
Yeah, sure, it might have hurt, but it was worth it. Got to play video games.
Alright, so you're not paralyzed then?
Yeah.
Your back is slightly hurt. How did you hurt your back?
So what I did was, I was on the bar, and I was tired of swinging on my legs, so I got off. Well, I tried to get off, but this person, who obviously wasn't looking where he was going, knocked into my face, and I flipped off the bar, and I landed on my back.
Oh my goodness.
So I fractured two of my vertebrae.
That sounds awful. Did you eat some good junk food at the party?
I ate some cake, some lemonade, some pizza.
No ice cream then?
Mm-mm.
Alright, pizza. Pizza's just as good. Alright, say bye-bye.
Bye-bye. I need one.
Alright, that was my daughter Maya. She is 8 years old. Okay, so these are the results of substituting each of the three vertices into the objective function. And as you can see, we have a maximum value of 8 coming from this point right here. And we have a minimum value of 0 coming from 0, 0. So this is how you should record your final answer. Alright, 2 more to go. Alright, all of these are horizontal and vertical lines. Alright, these x ones are vertical. And the y equals ones, well, you know, they're inequalities, but they are horizontal. So, when I look at this, I think x equals 0. That's a vertical line at 0, which is the y-axis. Like this. It's going to be a solid line. Okay, let's just face it. All of these are solid lines because they all have the little equal. In fact, every equation on this whole paper is a solid line because they're all or equal to or equal to. If any of these had been just less than or just greater than, please understand that they would have been dotted lines. Alright, so none of these will be dotted lines. Because this one is greater than, then it's going to be above. Oh, wait a minute, sorry. There is no above for a vertical line, so we'll have to think left, right. And so, x values are greater going to the right. Like this. Alright, next equation. I picture x equals 3, which will be a vertical line at 3. Like this. This one, because it's less than, we're going to go left. Alright? Remember, only x values we go left, right. Most of the time we're doing above and below. So for these down here, we'll be doing above and below, not left, right. Okay, so anyway, we have to do to the left of this. Illustrate that we have to be on the left side of this line like this. By the way, some of you, when you go to show which side of the line you're on, you're doing scribbles or something like this. That's too big. Okay, some of you are doing your scribbles like this. Alright, that's just impossible to read. I can't tell where's your line, and what part is the little shading. I'm going to recommend you do it like this with these little lines like fur. Alright, looking at this equation, I'm thinking about y equals 0. Remember, y equals 0 will be a horizontal line at 0, like this. And because it is greater than or equal to, I will have to stay above this line. Alright, and again, don't put a bunch of scribbles. Just show the above by doing this. Okay, just put a little fuzz on it. Okay, so far that puts us inside of this little pocket. Alright, would be to the right of the blue, left of the red, and above the purple. So far we're in here. But there's one more equation, one more inequality. Yeah, okay, and this again, when I look at this, I think y equals 5. And so that will be another horizontal line at 5, like this. Now, because this is less than or equal to, it tells me to stay below this line. And please show that you stay below by doing this. No more scribbling. Okay, so hopefully you can see that this rectangle here is going to be the feasible region. So this is the feasible region. And these are the vertices. 0, 0, 0, 5, 3, 5, and 3, 0. So once again, we need to substitute these vertices one by one into the objective function, which is just c equals x plus y. Okay, so if I do 0, 0, that'll just be 0 plus 0, which is 0. If I do 0, 5, this is 0 plus 5, which is 5. If I do 3, 5, that's just 3 plus 5, which is 8. And if I do 3, 0, that'll be 3 plus 0, which is 3. So you can see that we have a minimum value of 0, and we have a maximum value of 8. So this is how you will record your answer. Okay, alright, we need to do that one more time. For problem number 9. Okay, for problem number 9. When I look at this, I think x equals 0. That is a vertical line at 0, which is basically the y-axis. I don't know why I said basically. It is the y-axis. Now, when I'm dealing with x's, this is the only time that I do left-right. So because this is less than, I will shade to the left. And hopefully now you understand that I don't want any scribbles. I just want some fuzz, like this. When I look at this, I start by thinking y equals 4. And I know that's going to be a horizontal line at 4, like this. Because this is less than, I'm going to shade below this line. Please show your initial shading like this, no scribbles. Okay, so that's that. Now this other one, the final equation needs to be rewritten to get y by itself. So we're going to need to subtract x from both sides. So that's going to give us y is greater than or equal to negative x minus 1. When you go to graph this, imagine that there's a 1 right here. So it's like negative 1 over 1. So we're going to start off at negative 1. Should be right here. And then we're going to go down 1, right 1. Always go to the right. Okay, so these are the points that we're going to have. You can go ahead and connect the dots. Alright, so this is the line. Because this is greater than or equal to, we are going to shade above. Okay, so we will put just a little bit of shading on the above side of the line. Alright, please do not scribble anymore. Instead of scribbling to show your shading, just do this. It's much neater. And more importantly, I can read it. So hopefully you can see that this triangle here is going to be the feasible region. Alright, it's the part of the graph that satisfies all three equations. It's below the red, to the left of the blue, and above the purple. So now we can state the vertices. Alright, we have one vertex here at negative 5, 4. We have another vertex here at 0, 4. And we have another vertex here at 0, negative 1. So these are the three vertices. So remember, the objective function is c equals x minus y. So we need to substitute each one of these into this function. So I think I'll just start with negative 5, 4. And that's negative 9. And then we'll do 0, 4. And that's going to be negative 4. And then it's going to be, we'll do 0, negative 1.
In secrets?
Now be careful. We have minus negative 1. Remember how do you handle it when we do minus? Guys.
Sorry.
How do we handle it when we have minus a negative 1? We add. So this is going to be the same thing as plus 1. So that's why it's just going to be 1. Okay, so that means we have a maximum value of 1. Not much of a maximum, but even a small positive number is bigger than any negative number. And that came from this point right here. And then we have a minimum value of negative 9, which came from this point right here. So you can go ahead and record your answer like this. All right. So this has been a good introduction into linear programming. The next level is to start doing real-world problems where instead of having just anonymous functions that don't mean anything, these functions will be things like profit or cost. And if we were talking about profit, we would want to have the maximum profit that we could possibly get. But if we were talking about cost, we would want to have the minimum cost that we could possibly get. Alright, but for now, we're done. I will see you on the next video.
Let's do the dance.